Okay, question 6. Two forces of magnitudes F1 and F2 act in opposite directions on a block which sits atop a frictionless surface. Hey, here's another frictionless surface, as shown in the figure. Initially, the center of the block is at position x sub I. At some time later, the block has moved to the right, and its center is at a new position x sub f. What is the change in the kinetic energy of the block as it moves from xi to xf? I'm just looking at the answers here. There's 0, there's some products of forces, or impossible to determine without knowing the mass of the block. Well, what I'm going to do is use the work kinetic energy theorem, right? Which states that the change in kinetic energy is due to the net work theorem. So delta K is equal to the work net, which is equal to the net force on the object dotted with the change in its position. So what's going on here is delta R is equal to the final x sub f minus the x initial, and that is to the right. Now there will be some, again, gravity pulling the block down, but it'll be cancelled with the normal force pushing the block up. So the net force in the y direction will be 0, but the net force in the x direction, F net, is going to be equal to the F1, which is in the positive x direction, minus F2. So and this is to the right. So when you dot product those two vectors, they're in the same direction. So theta equals 0 degrees. So the work net just equals F1 minus F2 times x final minus x initial. So looking at those equations, I want the, let's do this right. F1 minus F2 times x final minus x initial, so the answer is B.